Good afternoon. Welcome to the Embedded Executive Podcast. My name is Rich Ness. I am with Embedded Computing Design. I'm here with Rob Oshana, the Senior Vice President of Software and Digital Platforms for Analog Devices. How you doing, Rob?
I'm doing good, Rich. How are you doing?
Just fine. Thank you very much. Timely podcast because you guys just made an announcement that I want to dive into, but for a particular reason. I mean, it's a great product on its own, but what makes this stand out for me at least is how you've sort of integrated everything into one cohesive package. A lot of the AI announcements that I see might be from a chip vendor, and they say we have the best piece of silicon out there, and in a lot of cases it's actually true. However, you have to go somewhere else if you want the tools. You have to go to a third guy if you want to integrate an operating system, and the hooks aren't in there, and it's just not easy. And AI on its own is hard enough. So
Yeah.
why make it even harder for an engineer? So I want you to explain to me what you guys have done and how you've been able to do that. And then if you can remember all these questions, what does that mean for the engineer? How does he roll that out into his design?
Yeah, no, Rich, that's a great question. And you're right. We don't want our customers to have detailed knowledge of AI, ML, or PhD, or even be able to navigate all these different technologies and tools. So from the very beginning, when we started building our platform, CodeFusion, we kept that in mind, and we built it not only to be open, so we can build a community around it, and others can contribute and participate in that community. But from the very beginning, we looked at user experience and designed that in from the very beginning, because we knew that at the end of the day, with these complex heterogeneous processors that include an AI accelerator, as well as DSPs and cores and everything else, we've got to make the user experience easy so that our customers can get productive and time to market. And the way to do that is with the right levels of abstraction built into our tools, and we've provided that. And we've provided that at the driver level, at the OS level, and even at the HAL and application level. So our customers can come in at different levels of abstraction depending on where they want to operate from. And that's I think what we achieved with CodeFusion.
Okay, can you clarify that? What do you mean by coming in at different layers of abstraction? What does that mean?
Yeah, that means some of our customers may want to build their application right on top of a driver, no OS. So OS kind of bare metal applications. Others want to come in at the OS level, like Zephyr or Linux, and they want to build their application on top of an operating system. So these are what I mean by different levels of abstraction. Even above the operating system, you may want to, or we do provide a common HAL, hardware abstraction layer, where the customers can operate in even a more abstract layer on top of libraries and other useful software. So that's what I mean by they can operate at different levels of detail or abstraction.
Okay. And what's the new part about this? You guys just announced this week, as a matter of fact. What is this announcement? Because
Yeah,
CodeFusion itself is not new.
right. CodeFusion's been out there and it's been doing very well. And yeah, just as a reminder, three major components: an IDE, a software development kit, and a bunch of config tools. And again, it was designed to be extendable, not just through VS Code, but other forms of extension and scalability. So what we added this time is additional add-ons, if you will, additional scalability to support AI. So we built in the capability of our customers to be able to bring, for example, their data or their model and integrate it and literally deploy it onto a piece of silicon through our tools very easily. So think about it as an open but end-to-end AI workflow concept, so that you can, again, start with your model, you can tune it, you can optimize it, deploy it, profile, the whole end-to-end workflow. Just like the rest of CodeFusion supports the entire workflow, we're now doing that or providing that for AI.
Okay. Are there particular applications that this is most suited for?
Yeah, we built this to support our main vertical applications, so primarily automotive, industrial, healthcare, data center, and consumer, and even aerospace and defense. So it supports those in a pretty seamless way. The workflow is pretty consistent across those applications.
Okay. Analog Devices is a pretty big company, and you guys do lots of different things. Are there hooks built in to build out a complete system beyond the MCU and some of the peripheral stuff?
Yeah, that's a great question. Actually, because we have very uh, differentiated signal chains, our analog portfolio, we've got thousands of these signal chains. We wanted to make it easy for customers to take either one of our MCUs or other MCUs and integrate that easily and seamlessly into one of our analog signal chains. And so CodeFusion provides that capability of being able to do that, selecting a signal chain and quote unquote, attaching it to an MCU of choice. Doesn't have to be ours, but we make that easy either way by providing frameworks for driver creation and OS integration. Rich, one of the things when we first launched CodeFusion, we chose, at least from an RTOS perspective, Zephyr is our supported RTOS. We'll support others, but Zephyr was our default. So if you want to use something in the Zephyr community, we can easily interrogate that MCU and auto-generate the drivers based on the peripherals in the device tree of that Zephyr MCU. We all through open source. So it's actually pretty easy to provide our customer whatever they want, whatever combination of analog and digital in our environment through CodeFusion.
Does Zephyr lend itself to a particular application?
Well, yeah, a lot of it is for these. It's getting better. It started off in mostly consumer, but now we're seeing Zephyr in automotive, industrial, and even aerospace and defense. So it's becoming. It's not just a kernel like FreeRTOS. It's a whole environment now, Rich. So it now supports many other different types of applications.
So going back to what we started with this platform approach where you have the integration of the various tools. I know it's not easy to do, but why aren't other people using the same approach?
Well, I think, we came at this from the perspective of making everything open in order to build a community around us. Others have a little bit more of a walled garden. We just decided we wanted to take an open approach. It was a risk at the time, but I think it's paid off. I think the second thing that motivated us to kind of take a slightly different direction is with our signal chains, we can produce very interesting data. And we combine that with AI, we call this physical intelligence. It's essentially being able to integrate AI with the physical world. And what I mean by that is the electrophysical domain, where we're really good with our signal chains. So we took a kind of an AI analog physical intelligence perspective, at least in this new release of CodeFusion, that I think is ahead of some of our competition in thinking this way. And then we made it open on top of it. So much more of a integration of analog than I think others have been doing to this point. So we just thought ahead from the beginning on this one.
Very good. So in my head, I was going to ask you, what's the starting point for somebody? And you'd probably say, go to analog.com. But what are the prerequisites? What do you need to know to get started in what's a fairly complex AI world?
Yeah, definitely. I think we wanted to make it easy to find and deploy not just a model. Like, so you hear about customers want to build these AI models. Okay, that's fine. And we provide that, and we provide a little hugging tree capability so the customer can find that model, do what's called graph lowering, deploy that model to our silicon. But in addition to that, that can be difficult, Rich. So what we do is we provide all the reference code to be able to plumb an application to ingress data, do the inferencing, egress data, and all that sample code. We provide all that in optimized libraries so that customers don't have to do that themselves. And so it makes, again, it makes it a lot easier to deploy a full application based on AI as instead of like bits and pieces that can happen if you're not taking a system view.
So is now the right time to jump in? I mean, will it get easier down the road or?
Yeah, I when I tell people, and I've been through the DSP era too, and you saw that start off very complex. You needed to be an expert in signal processing, and you saw over the years via tools and other forms of abstraction and code and everything else, DSP got easier and easier. I think with this, it's kind of sort of the same. I think you're going to see more and more tools getting deployed, more code and libraries and other capability that will make AI and ML easier. And I think it's not exactly apples to apples, but it will continue to get easier over time. I think it has to if we're going to deploy this technology at scale in the industry.
Awesome. Thanks, Rob. I appreciate taking the time to explain this. This is cool stuff.
Always great talking to you, Rich.
That was Rob Oshana, the Senior Vice President of Software and Digital Platforms with Analog Devices, and I am Rich Nass with Embedded Computing Design.